Welcome again to today's class on statistics. In today's class, we want to discuss the topic analysis of bioassay. Yes, this is one of the statistical topic we have. This bioassay you are seeing is gotten from the word biological assay. So it is shortened to be bioassay. So biological assay is what we call bioassay. But before we go in details to discuss how we can analyze a statistical problem given to us on bioassay, let's first and foremost discuss what an assay means. Yes, what does the word assay, what does it mean? An assay is a quantitative or qualitative test of a substance to determine its components by measuring its effect on a test of specimen against that of a standard substance. I take it again. An assay is a quantitative or qualitative test of a substance to determine its components by measuring its effect on a test of specimen against that of a standard substance. What do we try to explain? When you hear the word quantitative, it means that you are checking if the outcome you have is measurable. If the outcome you have is measurable, you can quantify it, you can measure it out and know the value it is. You say it's a quantitative. But when the outcome you got is not measurable, you can't quantify it, you can't know the value, amount it is, you say it's qualitative. Yes. So when we are checking the quantitative or the qualitative test of a substance to determine its components by measuring its effect on a test of specimen against that of a standard substance, we say you are discussing or you are experimenting on assay. Okay? Examples of assay. Examples. Number one, paternal assay. Paternal assay. Number two, stress assay. And number three, biological assay. Yes, these are examples of bioassay. These are examples of assays we have. Paternal assay, stress assay, biological assay, which we call bioassay. Now, in this video, we want to focus our study on analysis of bioassay. Let's first and foremost check out what does bioassay mean. Bioassay, as I stated before, that it can be called biological assay, simply mean you are experimenting with living tissues. You are experimenting, you are assaying the living tissues like plant, animal, bacteria. You are using any of these living organisms to do your experiment. That is what we'll talk about bioassay. When we'll go into pharmacology in details, you'll be seeing a lot of terminology, in vitro, in vivo, and others. This is to tell you living tissues, the living organism are what used in such experiments. That means when you want to perform experiment on bioassay, three things are what you look at. Number one, you talk about what drug am I to use in such experiment. Another name for drug in this regard can be called the stimulus. The stimulus. You can also ask, what type of living organism am I talking about? Is it living organism, so to speak, or is it living tissue? Which one do I want to make use of? The living organism or tissue or organ, whichever one you want to use, but it must be a living thing, so to speak. Yes, it can be from plant or animal or from bacteria, etc. So from any living organism, so to speak. Then you now check the response. What is the response you get when this is put into this? So what are we trying to say? When you take a drug, when you want to perform experiment on bioassay, it involves or it comprises taking a drug or a stimulus and inject it into a living organism, living tissue, living organ, whatsoever, but it must be living, it must be alive. You understand? So you take the drug, inject it into that living thing, so to speak, and you check the response. What will it cause to that organism? Is it going to stop a particular thing, or is it going to cause a particular thing? That is what the response will be checking out. Remember, we said if we are checking whether it is yes, it's caused this, no, it does not cause this, yes, it wasn't this, no, it does not wasn't it, you are checking the qualitative aspect of it. Are you getting it? But if you are now checking the quantity, the amount, are you getting what I'm saying? At which it costs that particular thing, you say what? We are talking about the quantitative aspect. That is, you are trying to measure out the quantity, the level, the amount at which it's able to cost that thing you are talking about. You get the point? Let's take, for example, Mr. A just made this hypothetical statement. What do we mean by hypothetical statement? It simply means he made a statement which he has not verified. That is, he just made a statement on what he thinks. Yes, he has not verified it. And that statement goes this way: that if you are having malaria caused by Plasmodium falciparum, yes, that what you do is get this leaf, use water to squeeze out the extract of it, and after squeezing out the extract of it, drink it for 3 days, and it will cure the malaria. Yes. How will you know what or if what the person just said, what Mr. A just said, is correct or is true? What do? You just do what he asks you to do. Get water and squeeze out the extract of this leaf. That extract of this leaf will be called the drug or the stimulus. Then drink it. In that case, human being is a living organism that is used in that experiment. So when you drink it, what will happen is we are looking for response. What type of response? Qualitative response, qualitative outcome, because it will not be measurable. All you are trying to check is, after drinking it for 3 days, will the extract of this cure the malaria the person or the malaria patient have? Are you getting what I'm saying? Then after the 3 days, if he cures it, you say yes, this leaf contain anti-malaria agent. But after the 3 days of taking of this, and this malaria is getting worse and worse, it means that this leaf does not have any anti-malaria agent of it. Like the API of this is not anti-malaria agent. I get what I'm saying. So what you are focusing to discuss when you talk about qualitative is if it does stop or if it does not stop, if it cures or if it does not cure. That is just what they are checking out. You get the gist. But when you want to discuss the quantitative aspect, wow, you have to embark on experiments that will help you see how to read value the degree at which it cures malaria. You can also bring a standard anti-malaria drug like ACTs, artemether lumefantrine, brand of or type of anti-malaria drug, anti-malaria agent, so to speak. Okay, so what you need to do is you just the last time we performed experiments on checking the efficacy and potency of two drugs, comparing their efficacy and potency. We use some equipment like chymograph and others. You understand? And we use intestine of guinea pig. That means we are checking the antimotility of the agent, whether the agent can cause antimotility or not. Are you getting what I'm saying? So what I'm just trying to tell you is that there are equipments you have to get. You want to check the quantitative aspect. It is this equipment that will help you to read off or get the value at which, or the quantity or the degree at which this cures malaria or not. And you can even compare it with already existing anti-malaria agent like artemether lumefantrine, so as to know whether the extract of this is a better anti-malaria agent than artemether lumefantrine, or whether artemether lumefantrine is a better anti-malaria agent than it. This is what you will be able to get in quantitative aspect. So quantitative outcome or quantitative aspect of bioassay, the quantitative response of it, helps you to do comparison, helps you to know whether the test substance is more efficacious, more potent than what the standard own, or whether the standard own is more efficacious and more potent than the test substance. So there must be equipment you use. You don't just get the quantity aspect of it, the quantitative aspect of it, by merely giving it to the person. He drinks it, he says it stop malaria or it does not stop malaria, and you're getting the quantity aspect. No, you don't do that. You get equipment that will be reading off the degree at which it's a particular agent or not. Yes, you get equipment that will help you to do that. So we are saying in essence that drug or stimulus, living organism and response are the makeup of the structure of bioassay, are the makeup of the structure of what? Bioassay. So these three things make up bioassay. Remember, remember, when you are talking about qualitative, you are checking whether it cures this or it does not cure this. So it's not measurable. But when you are talking about quantitative outcome of it, it means you are checking the quantity at which, the degree, the extent at which it does a particular thing or not. And you must have equipment necessary for that, so as you'll be able to get it. If you do not have the necessary equipment needed for you to what? Get the quantitative aspect of it, you will not be able to get it. You can't get the quantitative aspect by merely giving the drug to that living organism and you get the quantitative. No, you have to bring needed or required equipment so as to get every information in terms of quantitative aspect needed. Okay, now let's look into some of the questions one can be asked in this topic, analysis of bioassay. Yes, let's look into some of the questions one can be asked in this topic. Number one is relative potency. Relative potency. One can be asked to find the relative potency, so to speak. This relative potency is denoted with this symbol equals to mean of the standard test all over mean of the what? Prepared test. This is the formula for finding relative potency. This is called mean of the standard test. This is called mean of the prepared test. Are you getting what I'm saying? So all you just need to do is that you say this equals to mean of standard test. Then this one is equals to mean of prepared test. Then another question one can be asked in this topic, analysis of bioassay, is confidence interval. Confidence interval. This confidence interval can be packaged this way. Yes. What do we mean by RU? RU simply means upper bound limit of the response. RU simply means upper bound limit of the response. So we call this upper what? Bound limit of the response. And we call this lower bound limit of the response. So how do we find that? To find that, you say the relative potency plus or minus bracket T level of significance all over 2 NES plus NEP minus 2 times square root of variance of the relative potency. So what am I saying? Relative potency plus or minus bracket T alpha over 2 NES, that is sample size of the word standard, sample size of the prepared, minus 2 minus 2, then times this. That is how to what? To find the confidence interval. So this relative potency plus this whole value will be giving you the upper bound limit of the response, whereas this relative potency minus the whole of this value will be giving you lower bound limit of the response. Are you getting it? So you use the plus sign to get the upper and use the minus to get the what? Lower. Do you get what I'm saying? I'm just discussing possible questions they can ask you in this topic, analysis of bioassay. Another question they can ask you is variance of relative potency. Variance of relative potency. And it is S squared all over mean of the prepared test squared bracket. When you say S squared all over mean of the prepared test, you now say 1 over n plus relative potency squared all over what? N. So that is how to get it, where n will be equals to NP plus NS. When you add the sample size of the prepared test, with the sample size of the what? Standard. You see, that prepared test is that extract I talk about. The standard is already existing one we know. I use a leaf to talk about the extract of a leaf is called prepared test. Then the standard, the artimetal manufacturing own, the already existing one is the what? The standard. So when you add the sample size of prepared test plus the sample size of the standard together, you get n. But in a situation whereby NP is equals to NS, say automatically that it will be equals to n, the total sample size. A situation whereby this is equal to this, say is equal to what? The total sample size. Don't just add them again. You get the gist? Okay. Then that one there. Also, note that S squared is equals to SS squared plus sp squared all over NS plus NP minus 2. So the variance, this is the variance. So the total variance we are talking about is variance of the standard test squared plus variance of the prepared test squared all over sample size of the standard plus sample size of the prepared minus 2. You'll be able to get the value of S squared you have to put here. Are you getting what I'm saying? Then another thing that they can also ask you is the precision estimate. Precision estimate. How do we sort it out? When they ask you to get the precision estimate, it simply means the relative potency plus or minus square root of the variance of the relative potency. Wow. So precision estimates also have the upper bound limit of it and the lower bound limit of it. So when you get this plus this, you get the upper bound limit of it. When you now say this minus this, you get the lower bound limit of it. I'm speaking in parable now, right? Okay. We'll go to live question. For you to use the live question and see how you can appreciate this we talk about. We have a lot of things we need in this topic. You will need a 4-figure table containing the T distribution test, student T distribution test. We will need a 4-figure table containing student T distribution test. We need a calculator, a functional calculator. Yes, these are the two things we need to sort out questions in this topic. Okay, let's check the question.